Is it correct to think that in the 8-group classification, there are many conductors in the 3rd group metal, many semiconductors in the 4th group carbon group, and many insulators in the case of 5th group and above? Generally speaking, it can be a bit of an oversimplification to summarize these general characteristics of elements in the 8-group classification for the 3rd group metal, 4th group carbon group, and elements above 5th group. The properties of materials such as metals, semiconductors, and insulators can vary depending on the atomic or molecular structure, electron configuration, bonding form, temperature, pressure, and other environmental conditions of the element. Here are a few things to consider. 3rd group metal. In general, 3rd group metal elements, for example, aluminum, iron, copper, are classified as metals with high conductivity. However, not all 3rd group metals are conductors. For example, beryllium, B, is classified as a 2nd group metal but is a conductor. 4th group carbon group, 4th group elements, carbon, silicon, etc., are classified as semiconductors or nonmetals. However, some 4th group elements also have metallic properties that are not semiconductors. For example, tin, Sn, and lead, Pb, are not semiconductors but metals. Elements above 5th group. Elements above 5th group have a variety of properties. Some are classified as insulators, while others may have semiconductor or metallic properties. Therefore, the 8-group classification helps to group elements roughly, but the exact properties of each element can vary depending on the electron configuration and chemical structure of that element. More detailed information and exceptions must be considered to understand and classify the properties of elements. The 8-group classification can be a helpful way to group elements, but it is important to remember that these are just general trends. The specific properties of an element can vary depending on its electron configuration and other factors. When you allow current to flow through a conductor, electrons move readily, whereas in the case of insulators, they do not move well. Is this related to the structure of molecules or atoms? Yes, the structure of molecules or atoms is mainly related to the electrical conductivity of a material. Whether electrons move well is related to the free mobility of electrons within a material, which is affected by the electronic structure and bonding state of the material. Conductors, metals. Metals are very good at conducting electrons. This is related to the characteristics of metal atoms. Metal atoms have a large number of free electrons, and these free electrons move in a sea of electrons within the metal material. The metal structure facilitates the movement of electrons between metal atoms. Semiconductors. Semiconductors have lower electron mobility than metals, but they are materials in which electron movement is possible under certain temperature or energy conditions. The electron mobility of semiconductors is related to the electron energy levels, and it can vary depending on external factors, temperature, impurity addition, etc. Semiconductors have an energy band structure that slows down the movement of electrons. Insulators. Insulators are materials with very low electron mobility, and electrons hardly move. This is due to the electronic structure of the insulator, which restricts the movement of electrons. Insulators often have a filled electron energy band structure, making it difficult for additional electrons to move. Therefore, there is a close relationship between the electronic structure and the electrical conductivity of a material, and the electronic structure of a material plays an important role in the flow of current. This is why conductors, semiconductors, and insulators have different electrical conductivities and have different uses and properties. The structure of molecules or atoms affects the electrical conductivity of a material by determining the mobility of electrons within the material.